Ladies and gentlemen, once again, you are cordially welcome to this class. We are looking at analysis of variance independent ANOVA test. This is it. Okay, independent ANOVA. That's what we are looking at. What is it? Well, it's a parametric test. In this table, we have been going through it. We've looked at one sample hypothesis. We've done that. We've also looked at two sample hypotheses, and we used them on Whitney. We are looking at ANOVA. And once you learn this ANOVA, you can apply it to the repeated ANOVA, Kruskal, Wallis, and the Friedman, all of which are non-parametric tests. Okay, so that is what we want to look at now. ANOVA looks at 3 or more samples. ANOVA looks at 3 or more samples. The t-test we dealt with, and the Mann-Whitney U-test, they look at 2 samples or 1 sample. ANOVA looks at 3 samples. And we are going to use the same steps in hypothesis testing to go through this. Okay. Who can remind us of the first step in hypothesis testing? Who can remind us of step 1 in hypothesis testing? Who can raise a hand and tell us? Yes, Marcus.
Formulating the hypothesis.
Thank you. So the first step is to formulate the null and the alternative hypothesis. That's step 1. Okay. Basically, that is the first steps that we looked at. Okay. Formulate the null and the alternative hypothesis. The step 2. Who can tell us the step 2? The step 2, Tariq Sam Abaka. Yes, Tariq.
You compute the statistics.
And then the critical value. You missed that. Okay. So the next thing you do is that you compute the test statistic and the critical value. Okay. You compute the test statistic and the critical value. Step 3, and I hope you are not looking on your notes or anywhere before mentioning these things to me, because that means that you are cheating yourself. Okay. Step 3 is to find the p-value and compare it with alpha. You find the p-value and then you compare it with the level of significance. Okay. With the level of significance. And the step 4, who can tell us the final step? The final steps in hypothesis testing. Sandra.
You make a decision, then conclude.
You decide and you conclude. You decide and you conclude. So that is it. Decide and then what? Conclude. Decide and then conclude. So we are going to go through all of these steps in the world of 3 or more samples. 3 or more samples. Okay? 3 or more samples. So to do that, and 3 or more samples, we need to understand how you do the formulation of ANOVA. Now, to say 3 or more samples will require that the samples are 3 or 4 or 5. And so, and of course, it's a parametric test. If it is a parametric test, then it means that we are going to talk about the mean and not the median. You remember that parametric test, we focus on the mean. The non-parametric test, we deal more with the median. Now, the best way to understand is that I'm going to take a typical example of real-life situation to show you. So here we have 3 different kinds of MBA groups. We have the regular MBA group. These are their salaries I'm going to show you. We have the weekend MBA group. These are their salaries I'm about to show you. And then you have the executive MBA. The richest people, the richest. These salaries I'm about to show you are in thousands of Ghana cedis. Okay, the salaries are in thousands of Ghana cedis. And so, how much are they earning? The MBA groups, the RMBA, the regular MBA groups are earning 1,000, 2,000, 3,000. The weekend MBA groups are earning 4,000, 5,000, 6,000 every month. The executive MBA, they are earning 7,000, 8,000, and 9,000 every single month. Now, these salaries in reality might not reflect that, because somebody is sitting here, he's an executive MBA, the person is telling himself, really? Do you know what is in my pocket? Have you ever been in my umbrella? Because that person might not necessarily be earning this, but rather in the RMBA column. Where do you think the lecturers will be? The lecturers, are they before the RMBA, after the weekend MBA, or after the executive MBA? Where will you place your lecturers? I'm going to laugh. I can imagine some of the answers. Okay. Where do you think the lecturers are located? Amanda has given an answer. This one, you don't even have to raise your hand. You just have to type the answer. It's easy. Okay. Okay. But when you say, Amanda, when you say after, you've not spoken. I say after RMBA, after weekend MBA, or after EMBA, or before. Which is which? Okay. Okay. It's so funny. Some of the answers. Oh, goodness me. You people, you have rated some people so well, eh? But that is good, eh? Oh, goodness me. I wish I had not eaten. Okay. Some of you have really showcased a lot. Trust me, ladies and gentlemen, sometimes not all that you see are glittering. Okay. Not all that glitter is also gold. So you let me keep quiet here. When I said that somebody is changing his answers. Anyway, so these are the different categories of MBA groups. Now, the simple answer is, and this is very important because this is a question ANOVA is attempting to address. Okay. Is there a statistically significant difference? Okay. Is there a statistically significant difference in the mean salaries? In the mean salaries across these MBA groups? Okay. Is there a significant difference in the mean salaries across these MBA groups? Is there a significant salary difference? Because in principle, it might look like there is a difference, but you got to subject that difference to statistical torture. There and then you can appreciate whether there is a difference. And so ANOVA helps us to do that. And we are going to do that using the steps in hypothesis testing. So step one is to formulate the hypothesis. Now I've already told you that here we use a means, and this is represented by mu. So mu1 is going to be the population mean for group 1. Then you have mu2, and then you have mu3. Now this is because the groups are how many? There are 3 groups. And because there are 3 groups, the means that we are going to consider are how many means? They are 3 means. If the groups are 5, we will have 5 different means. And so we're going to formulate a hypothesis. How do you formulate a hypothesis? Well, the key thing, and with ANOVA is a standard thing, is to find the difference. Okay. So the null hypothesis is always standard. Okay. The null hypothesis is saying that, oh, what's happening to me? The null hypothesis is saying that the mu1 is equal to the mu2, which is also equal to the mu3. That's what the null is saying. The null is saying that there is no difference in the means. Take note, this will not change. It doesn't matter what. It will only change when there are different number of groups. For example, if there are 4 groups, then you will have equal to mu equal to 4. Equal to mu 4. But other than that, it's not going to be different. Now, the alternatives is not direct, because sometimes some people will think that because the null is equal to, then we are going to have alternative to be mu 1 not equal to mu 2 not equal to mu 3. That's wrong. That's wrong. Let me tell you why that is wrong. Because the alternative should indicate that mu I is not equal to mu j, okay, for every one of them. Every, let me just delete this. Mu I is not equal to mu j, okay, for every I j equal to 1 all the way to 3. Okay. So what the alternative is saying is that even if one of them is different from the other, it is an alternative to the first one. So you can have mu 1 equal to mu 2, all right? However, that will not be equal to mu 3. It's an alternative. It's one of the alternatives. Or you can have mu 1, okay, not equal to mu 2, but mu 2 is equal to mu 3. That's another alternative. Or you can have mu 1, okay, not equal to mu 2, not equal to mu 3. All of these are possible alternatives. And because they are all possible alternatives, okay, we can now say without a shadow of a doubt that this is the best way of writing the alternative hypothesis. So what you see here, okay, what you see, where is that? What you see here is an indication of the alternative hypothesis. Now, if you have more than 3 groups, like you have 5 groups, all you have to do is to do mu 4, okay, mu 4 equal to mu 5, and then come and change the 3 here to 5. That's it. And that is how you formulate the alternative hypothesis. So what is the alternative hypothesis saying? In reality, what it's saying is that at least one of the means is different. At least one of them is different. And that will nullify the null hypothesis. That will counter the null hypothesis. And so there's no specific trick on how to write alternative except what I've just given you. If the only difference is going to be when the number of groups are different. Okay. Now at this stage that we finished formulating, so in our own, the alternative hypothesis will not include these ones. Okay, it will not include them. It will be only up to mu 3. The next step in the hypothesis testing is to calculate the test statistic. Now the test statistic here in ANOVA is known as the F-test. Okay, that is the F-statistic. Now this F-statistic, you can only calculate it provided you've been able to create the F table or the ANOVA table, and then fill in those tables. And once you've been able to fill in those tables, you can now go ahead and calculate this F-statistic. So what I'm going to do is to give you the ANOVA table, okay, and then you can now write and follow me. Please, it's always important that you follow what I'm writing, because it helps you to, position it right inside your cerebral cortex. Okay. So the first thing we're going to have is a horizontal horizontal line, and we are going to have the source of variation as the first thing there. The source of variation. The source of variation. Then we will have another column which is known as the degrees of freedom. The degrees of freedom. We will have another column which is known as mean square. Mean square. And the final one is the F-statistic itself. Now, the source of variation, and of course, you have to create a horizontal line like this and like that. Now, the first one is the source of variation, and the source of variation, we have two of them. The first one is known as between group variation. Okay, that's the first one. Okay. It's known as between group variation. Between group variation. And the other one is known as within group variation. Within group variation. Now, I will explain it. Don't worry. I will explain it easily for you. And to explain this, let's go back to our data set. Now, look at the data set. If you look at just RMBA in the first column here, the RMBA, do you notice that there are differences within this RMBA? Do you realize that? Differences within. Now go to the WMBA, there are differences within. Now go to the EMBA, there are differences within. And these differences are what is known as the within group differences. The within group differences. So even if you look at them on their own, there are differences within. But what about across each group? Compare the RMBA group with the WMBA group. You will also notice that there are differences across the groups or between the groups. And they will capture those differences between the groups. So the ANOVA tries to look at not just differences within each group, but differences between the groups. And not only the big differences between the groups, but also the differences within the group. So we are looking at differences within the differences between the differences between the differences between the, and ANOVA comes out with a statistic, and then we'll juxtapose that against the origin. So we are going to look for the differences within and then the differences between. Differences within and the differences between. I think that I need to give you a new version of the table. Okay, a new version, because the table doesn't look nice here. I'm going to clean it and I give you a new version of the table because I missed something. So we're going to have this source of variation. Okay, we're going to have the sum of squares, the degrees of freedom, the mean square, and finally the F-statistic. The source of variation are between group variation and then within group variation. Okay. Between group and then within group variation. That is what you have there. Ouch. Something is not helping me today. Now, then we have the sum of squares. That's the SS. The sum of squares. Please note that. The sum of squares. Now, the sum of squares, they will capture for the between and for the within. The first one is known as the SSG. 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 That is what the first one we'll be looking at, the SSG. The SSG is known as the group sum of squares. And then the second one is the SSW. That is the within group sum of squares. Okay. So you have the SSW, the within group sum of squares, and then the SSG is the between group sum of squares. The way they actually have been indicated doesn't sound well with their acronyms that we've given to them. I'll take it like that. We'll come back to each one of these and then explain. Then you have the degrees of freedom. As you know, the degrees of freedom measures the level of the sample size. So usually there's a sample size. Now, if you look at the between group, Okay, because we are dealing with the groupings, the between, okay, the degrees of freedom will look at the number of groups less 1. The number of groups less 1. So that will be k minus 1. So k minus 1 will be the degrees of freedom, and then the n minus k will be the degrees of freedom for the within groups. Finally, I'm not going to give you the mean square, because the mean square is simply going to be the SSG divided by the k minus 1. That will give you the value here. And then the SSW divided by the n minus k, that will give you the value here. And then finally, the F-statistic. Okay? The F-statistic will be the value at the top here divided by the value at the down here. That will give you the F-statistic. And we are going to use the weekend MBA, the executive MBA, the regular MBA example to showcase all of this. So, what is the first thing to do? Well, the first thing to do, I'm going to use this section here. The first thing to do is to find the SSG. The SSG. And what is the SSG? Well, and I'm going to go to a new page. The SSG is a formula, and it's a formula. It's a very, very simple formula. If it was an exam situation, you will be given this formula, so don't worry much. It's a formula that says that you have the summation, and this summation is a big plus, okay, which starts from I, from 1 all the way to k, and then ni, and then we are going to explain each one of them. Brackets I bar minus x bar all squared. I know what you're thinking, but you see, just write it down. No matter how complex it is, no matter how anything it is, don't worry, just write it down. You just write it down, because as you write it down with your pen and paper, what is happening is that it's taking in. It is taking in. Okay, let's explain each one of these terms. It's very simple, actually. The K here, the NI is the sample size in that group. And in our case, we have different groupings, don't we? Okay, we have different groups. So the NI will be the sample size in the RMBA group, the sample size in the weekend MBA group, the sample size. And when you look at them, they are all 3. Okay, when you count them, they are all 3. So for NI, the I will be for each group, and that will be 3. Please don't think that it's always going to be the same number. In this case, it is the same number, but sometimes the first one will be 20, the second one will be 16, the next one will be 5. So you can have unbalanced panel. But what I have for you here is a balanced panel. Okay, so let's try to get a sense of that formula. Okay, so that formula says take that sample, multiply it by the mean. So x bar here is simply the mean. So x bar I is the mean in that group. The mean in group I. The mean in group I. So if you look at the RMBA group, you calculate, you add all the numbers, find the mean. You calculate all the means in the other one. You calculate all the means in the other group. Okay, that's it. I'll do that with you, so don't worry. Then the last one, the x bar. The x bar is the grand mean, the mama mean, the mean of a means. I don't like that last one, the mean of means. I don't like that one. Don't ever use that one. It's not good. The mean of all the means. No, it's not correct. But the grand mean. Otherwise, what some will mistakenly do is that they go and calculate the mean of the first one, the mean of the second group, the mean of the third group, then they go and find the mean of that and call it the grand mean. No. That's not correct. The grand mean simply means that to add all the numbers together irrespective of which group they go. So add 1 to 2 to 3 to 4. Okay, this is 4. To 4. Okay, to 5, 6, 7, 8. Add all of them together and then divide by the sample size. and that will be the mama mean, the grand mean. Okay, so let's try to do it all together. Okay, so we are going to take the mean, the sample size in the first group. And can somebody type for me the sample size in the first group is what? Just type it for me. Type it for me, the sample size in the first group. That is 3. Correct. And I'm going to take that 3. Then I bring a bracket, because according to the formula here, bring a bracket. Then I calculate the mean. So the first thing we want to do on the right hand side is find the mean in the first group. Call it x1 bar. Find the mean in the second group. Call it x2 bar. Find the mean in the third group. Call it x3 bar. So who can tell me, and I know you've written your table already. If you have not written down the table, you want to do that. Okay. So who can tell me the mean in the first group? x1 bar. Who can tell me x1 bar? Okay. Who can tell me x2 bar? Okay. And who can tell me x3 bar? x1 bar, x2 bar, x3 bar. Who is bold to give me all of them? Let me see the answers I'm getting. Okay. Somebody says, please, when you are writing, write the X so that I know which one you are talking about. Because some of you will just write 1, and I don't know which the 1 is for. Okay. So X1 bar Rekafori says 2. That is correct. Okay. X1 bar is 2. Okay. X2 bar, the mean in the second group, is 5. Almost all of you are getting it. Okay. So x1 bar is 2, x2 bar is 5, and then x3 bar is 8. Excellent. Majority of you are with me. Others are also with me. Okay, so we'll see. Okay. So this is these are the means in each group. So we're going to now find the grand mean. The grand mean. And the grand mean will require that you don't find 2 plus 5 plus 8 divided by 3. Okay, that is not the approach. That approach is wrong. If you happen to do that and you get it correct, it's coincidental. But that approach is not correct. The approach is to add the 1 to the 2 to the 3 to the 4 to the 5 to the 6 to the 7 to the 8 to the 9, 10. Okay, to the 9. And then once you add all of them, you get 40 what? 40 something, and then you divide that by 9. Okay, what will be the answer for that? What will be the answer? Okay, what will be the grand mean? The x bar bar, the x bar bar. What will be that answer? X bar bar. Excellent. Some of you are cracking it. Okay, some are cracking it. The answer is going to be 5. So the x bar bar is 5. Okay, that is the x bar bar. That is 5. Okay, that's a grand mean. So we are now going to use this principle to calculate everything. So watch the first thing I'm going to do now, because I'm going to let you come out with the answer for me. So follow me. You will now write n, which is 3 for the first group. Okay, that's what I'm doing for the first group, and then inside. So you get a first group like that. That's the first group, and the x bar is here. And you're going to have 3, which is the sample size, into bracket the xi bar, which is the mean in the first group, and the mean in the first group is 2. The mean in the first group is 2. So you write 2 minus the grand mean, which is 5. Then you square it. Then you do plus. Okay, you do plus. That is why this big summation sign is there. Then you do plus. Then you come to the second group. The second group, the sample size is what? 3. Into bracket the mean in that group. Okay, the mean in that group, and the mean in that group is what? 5. I kind of understand why this thing is happening the way it is. Okay, the mean in that group is 5 minus the grand mean. The grand mean is what? Is 5. Then you square that as well. Plus, the sample size in the third group is 3. The mean in that group is what? 8. The grand mean in the whole of it is 5. Then you square it. So we find the answer to this. Find the answer and tell me what you had. Make sure you are working it, because that is the only way you can crack it. Araba Akins, that is the correct answer, and this is the SSG. When you do that well, okay, this one, if you have a mathematical eye, you don't calculate. If you have a mathematical eye, you can pick the answers on the table. Let me show you the table. If you have a mathematical eye, you don't calculate. Okay, watch it. These are the answers. You just pick the answer like that. Okay, that's it. That's it. 5, 4, 54. You pick it. It's a permutative answer. Somebody is sitting there and says, calculate it, calculate it. It's not all of them that you have to calculate. It's a permutative answer. So that is SSG is equal to 54. Okay. And once you have that answer of 54, what you now do is that you take it to the table. Okay. So in the table, this section here will be 5, 4. We've been able to fill in that gap. Okay. We are now ready to calculate the next section, which is this box here. Once we are done, we'll calculate this one here. We'll now find this one there, and then we can easily drop them and then find this one, and finally we can find our F-statistic. So we are left with the SSW. Okay. There is a formula to finding the SSW. Okay. So what is the formula? Let's write it. The SSW is given by this beautifully fantastic formula. And I don't want anybody to just collapse, because this is not too hard to appreciate. It is summation I from 1 all the way to k, another summation, okay, j from 1 all the way to n, and that n is not just any n, it's just one of the n. You bring a bracket, you have xij minus x Ij minus xi bar all square. Believe you me, everything here you know it. For example, the xi bar, you know what it is already. The xi bar, every one of us know. It is the mean in that group, so that one we know. What we don't know is the xij, and it's actually simple. The xij is a number in each group. Okay, so the number 1 is Sij. Let me write it here. Number 1 is Sij, number 2 is Sij, number 3 is Sij, number 4 is Sij, 5 is Sij, 6 is Sij, 7 is Sij, 8 is Sij, 9 is Sij. So those numbers in each of the groups. And so what the formula is saying, forget about this summation, double summation, because it's just, as you add them, you are already taking care of the double summation. So, because there are a number of groups, you have to calculate the SSW for group 1. So you have to do SSW1, SSW2, okay, and then you do the SSW3, SSW2, SSW3. So that's what we are going to do, okay. And how do you do that? Take the first number, in this case number 1, minus the mean in that group, and then square it. And then add the second number minus the mean in that group, and then square it. And then the third minus the mean in that group, and then square it. So let's take the first one. Okay. So the first number is what? Number 1. So you take 1 minus the mean in that group. Now group 1, do you remember the mean there? What was the mean? What was the mean in group 1? It was 2. Excellent. So 1 minus 2, then you square it, plus the next number is number 2. So it will be 2 minus 2, then you square it. Okay. Then the next number in that group 1 is what? 3. So you do plus 3 minus 2, and then you square it. And then you find the answer. You find the answer. So do that. Find the answer and then go to the second group. Go to the second group. And again, if you have a mathematical eye, you don't calculate this. Okay. So, by the way, be careful with your minuses. Some of you can lose the minuses. 1 minus 2 is minus 1. Minus 1 square is 1. Plus 2 minus 2 is 0. So everything here is 0. 3 minus 2 is 1. 1 square is 1. So 1 here, 1 there, and that will give you a value of what? Of 2. And like I said, if you have a mathematical eye, you don't calculate the rest. So that is SSW1, 2. Can you calculate SSW2? Please do calculate SSW2. So that one is going to be taking the 4 minus the mean in that group, which was 5, squared. Then 5 minus the mean in that group, which was what? 5. And then you square it. Then 6 minus the mean in that group, which was what? 5. And then you square it. Okay, so that's the same thing you do. So you get 4 minus 5, then you square it, plus 5 minus 5, you square it, plus 6 minus 5, you square it. That will also give you 2. And again, if you have a mathematical eye, you will know that the other one will also give you what? 2. Now, this is not difficult, but what it takes is that it's annoying. It's annoying. Believe me, it's annoying. Sometimes when you're having 30 of these numbers going this minus that square, this minus that square, plus 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 this minus that, is so laboriously annoying. And that is it. It's not difficult, it's just annoying. But you have to have the patience of Job, go through all of these processes, and that will crack you. So SSW1, SSW2, SSW3, all of them, our final SSW will be equal to what? Will be equal to 2 plus the 2 plus the 2, and that will give you 6. So you now go back to your table and fit in that in your table. Our SSW is 6. Wow. Congratulations. You've been able to do that. And I'm telling you, that SSW calculation is usually the most difficult. But once you're able to crack it, you are good to fly. Okay, you are good to fly. Now, you are done with that. So that takes us to the next one, which is the K minus 1. K minus 1. Ladies and gentlemen, the K is the number of groups. K stands for the number of groups. So who can tell me the value of K? The number of groups. So who can tell me the value of K? So what do you think is K minus 1 now? Very good, Araba. Very good, Richard. Very good, Benjamin. Very good, Sandra. Very good, Emma. Okay. Excellent, Tariq and Augustine. What do you think now is the value of K? And the answer is clear, just as you guys are saying, the value of K is 2. Because K itself is 3. K is 3. And you can see that 3 minus 1, that will give us a value of what? 2. So K minus 1 is 2. That is the degrees of freedom for the numerator, for the between group. What about the N minus K? Well, the N is the overall sample size. If you count everybody, every observation in the sample. So what do you think is the value of N? And what is N minus K? N is overall sample size. So what do you think is the value of N? And what is N minus K? Excellent. Some of you are cracking it. The value of N is 9. And K, we already know K to be 3. So 9 minus 3, and that will give you what? 6. So ladies and gentlemen, we have been able to find all the values that we need. But right now, we have everything that we need to calculate the F statistic. Because the next section here is simply the 54 minus the 2. Sorry, 54 divided by 2. That will give us the mean squared, the group mean squared. 54 divided by 2, that's what you put there. And that is a value of what? 27. 27. So 54 divided by 2 will give you 27. And as for the 6 divided by 6, who doesn't know? Therefore, our F statistic is equal to what? You can tell us. Our F statistic is equal to what? Our F statistic is equal to what? Let me see. Okay. My screen is hidden, so I wasn't really calling people. Now let me see if I can be calling some people. The F statistic is equal to what? Yes. I want somebody to type the answer or raise their hand. The final F statistic, the calculated F statistic is going to be equal to what? 27. Excellent. Okay. Tariq and Araba cracked that. Okay, so that is 27. Now, why is it 27? Well, it is 27 because I told you that the value of the F statistic is the upper number here, which is the 27, divided by the lower number there. Okay. And that is 27 divided by 27, which will give it 27. This is the most difficult aspect of the ANOVA, which we have done. So, once you have found the calculated F, the statistic, the F statistic, what do? If you can remember, the next thing is to find the critical value. That's the next thing. Find the critical value. And there's a small formula for finding the critical value, not big. Okay, so the F critical, you might say, okay, is given by F subscript alpha k minus 1 n minus k. Okay. F subscript alpha, you write it down. F subscript alpha k minus 1 n minus k. Now we know the values of these already. You know that. We have the values of these things already. Okay. We know the values. We know that k minus 1 is 2. And we know that the n minus k is 9 minus 3, which is 6. And we know that whenever alpha is not given, okay, alpha is a level of significance. And in this context, alpha wasn't given. But whenever alpha is not given, what is the value of alpha? Who can tell us? When alpha is not given, what is the value? You see, the first person got it wrong. The second person got it wrong. Marcus got it wrong. Benjamin got it wrong. Because they were rushing. And when you normally rush, you get it wrong. Okay, it's not 5. It's not 0.5. It's 0.05. It's 0.05. Okay. And somebody, Augustine went to write 0.5 again. Okay. It's 0.05, which is another person goes to write 0.5 again. When I keep saying it's 0.05, the person is joyfully writing 0.5 again. So 0.05, so that's 5%. Okay. The default alpha is 5%. So this is going to be F subscript 0.05, comma 2, comma 6. The first number 2 is the numerator degrees of freedom, and the second number 6 is the denominator degrees of freedom. Now, anytime you are checking for the F critical or any of the critical values, you have to use a table. So at this stage, I'm going to show you the F table. On your screen, this is the F table. Look at it. Look at the F table. Now, the F table, there are two versions. The one for 0.05, which is 5%, which is what we have here. Okay. And then the second one is 0.01, which is 1%. That one is not here. It is in the next page. Okay. But since we are using the 0.05, I'm going to focus on that. Now, the first number that comes in our F critical, okay, the first number which we saw here, the first number is 2, and that is read always at the top. And then the second number, 6, is always read at the far left column. Okay, so the first number is read at the top. So when you look at this, you see some numbers in the yellow section. You pick the 2 from there, and then on the far left column, you pick the second number, which is 6. The meeting point is your F critical. Can you type your answer for me? The meeting point between these two numbers. What is the answer for the meeting point? Okay. If it was an exam situation, you will have all of these tables. Okay. The meeting point. What did you find? You can choose to copy what somebody is indicating, but you got to convince yourself. Okay. You know what somebody is doing? The person is joyfully copying and putting the answers down. That is also not bad. The correct answer, you are all right. Nobody has gotten it wrong so far. Okay. The correct answer is 5.14. 5.14. So we can now say without a shadow of a doubt that our critical F value is equal to 5.14. Now we go and handle the final section. Now again, in this section, I will not bore you in finding the p-value. I will not bore you, okay? But in some people can worry you to find the p-value. Okay? But here I will not bore you. But if you are using the software, you will need the p-value, and the p-value will be brought to you. Okay? But here I'm not going to worry you to find the p-value. So how do you conclude? How do you decide and conclude? Well, remember the decision. Okay, the decision rule is not different from all other decision rules that we know for parametric tests. The decision rule is simple, that if the F calculated is greater or equal to the F tabulated, then you should reject the null hypothesis. That's what it means. If the F calculated is greater than or equal to the F tabulated, reject the null hypothesis at the 5% level of significance. Okay. Now, looking at our F calculated that we had F calculated, okay, to be our F calculated. We found that, if I let me just wipe up this and then make it much more beautiful. Our F calculated, it was equal to 27. Do you remember? And now our F tabulated is 5.14. Should we reject the null hypothesis or we don't reject the null hypothesis? What do you say? Should we reject or we don't reject? Reject or don't reject? Reject or don't reject? And please never say accept. Okay? Reject or don't reject? We reject or don't. Okay, so we reject. Exactly. All of you are correct. We reject the null hypothesis at the 5% significance level. And therefore, what is going to be our conclusion? What is going to be our conclusion regarding the salaries across the different groups? What is going to be our conclusion regarding the salaries across the 3 different MBA groups? Who can tell me by typing or raising their hand? What is going to be our conclusion regarding the salaries across the mean salaries across the 3 different MBA groups? What is the conclusion? Who is bold? The conclusion. Okay, so in order to do that conclusion, you need to check the null hypothesis. Okay. And look at the null hypothesis. The null hypothesis said what? There is no difference. No difference. No difference at all in their means. Okay. In other words, the means are more or less the same. That's what the null is saying. The means are the same. But the question is, are the means the same? Well, if you look carefully now, look at it. Okay, then we have rejected the null hypothesis, which means that the means are not the same. Which means that there is a statistically significant difference in the means across the 3 MBA groups. Okay, so there is a significant difference, statistically speaking, okay, in the mean salaries. So on the basis of this, if there is a statistically significant difference, then we can now conclude that which group is the highest, which groups of MBAs are earning the largest salary, which groups are earning the largest salary now. Statistically speaking now, is the EMBA, exactly, it's the EMBA, because now, and we have to now indicate by how much. Now we can say that the EMBA on average are making what? 8,000 cedis. That is how much they are making on average. We can say that now with a statistical macho. Okay? without an iota of doubt, because we have a statistical backing. And that is the beauty of analysis of variance. So, ladies and gentlemen, that is how you handle it. Now, let me show you something. Everything, by the way, that we've done is in your slides. So, there's no problem with that. But watch this. Watch this. So, everything that we did is right here. So, this is for the 3 groups that we looked at. Okay. And of course, when you go through the slides, you see that I've worked everything. But look at these other groups. Okay. Look at these other groups. I just want to show you an example. Okay. I wanted to show you an example. Oh, okay. So that didn't really show. You will notice that, and I'm going to give you a typical example of what I mean. Okay. You will notice that, okay, someone has a question. So just look at this. Okay, this is RMBA. This is RMBA. Okay. Today I don't know what's happening to this thing. This is weekend MBA. This is executive MBA. This is MPhil. This is PhD. And you have different incomes now, 20. And all of these are in thousands, okay? 5, 6, 7, 1, 2. Okay, 3, 4, 9, 13, 6, 2, 8, 20, 1, 4, 3, 2. And then 3. Okay. So you can see these examples that I have here. You can see that the samples are different. Do you realize that? In fact, that's what you have in your slide, your bigger slide. The samples are different. Okay. And it can go anyway. And so once again, you can have different kinds of samples. And you can see that here, the groups are many and the samples are also a lot. So you can have different diversities of questions that will require that you do this at all times. At all times. And this is important. ANOVA is a very powerful methodology for looking at differences across groupings. But that does not mean that it is a final arbiter, because there is a powerful one, much more powerful than ANOVA, that establishes even causality in the process. And that's what we're going to look at next time, which is known as correlation and regression. So next time when we are looking at correlation and regression, we will now be digging deeper into all the things, the loopholes, the flaws of ANOVA, and then we shall now incorporate that in the final methodology that we are going to consider.